My name is Kingsley Eki. What you're watching is an engineering. Let's have a walk around of this platform. Okay, so let's show the structural members that make up this platform. To do that, I go to my structural tab, then come to this layer tab. I click this bulb-like icon to hide other members. Now, what we can see is the structural members of this platform. We have the footings, the HE beams, the gratings, the handrail, the channels, the stairways. This make up the structural member of this platform. Let's bring back the equipment and vessels. So I click this tab again, come to layer, click this icon. Click. It changes from blue to yellow. Okay. Let's look at the process vessels, the pressure vessels, the equipment, is the tank that make up this platform. So I zoom in. So we have here the test separator. If you look at the test separator, it has a manway by the side, another manway, a platform, the saddle, a liquid outlet, we have a gas outlet, we have the relief valve. Okay, there's a spectacle blind, is a tying point. We have a high pressure separator and a low pressure separator, LP. High pressure separator, HP. Okay. Then from there we have the flare knocker drum and the surge vessel. Let's go back to this separator. This is a horizontal two-phase separator. Either is it whether you're talking about the test separator or the HP separator, high pressure separator, or the LP separator. So it has the saddle, it has the shell plates that make up the length, and yeah, we have the ellipsoidal head. Okay, so on this such vessel, and there's a such vessel, there's the flare knocker drum. Let's have a look of it. I will hide this tank to have a proper look of this such vessel and the flare knocker drum. Click this, zoom in here, click on this. So right click and click hide objects. It's not deleted, it's just hide temporary. Okay, so I come to my icon to rotate, so we can hide the grazing as well. Let's go to tab, butter. Sorry about that. From here, so hide this grazing. It's hidden now, so you can have a proper look at it. So we have this is the flare knocker drum. You have the skids, the share plates that make up the height of the tank, the elucidator head, and a platform. So also have a platform at the middle. So this is the search vessel. Have the skid, the skids, a platform for operator to work. We have the shell that make up the heights, the shell plates. We have here the elucidator head and a platform as well. Okay, so from there we go to the pump. Go in. There's the pump. So you have the strainer. The strainer, you have the check valve, and you have the gate valve there. Let me bring back our storage tank. Okay. So let me click on this to navigate. On the storage tank, zoom in. You have the base plates. We have the shell plates that make up the chassis of this tank. We have this spiral stairway. We have a manway in this part, and we go to the top. We have the roof, the cone roof. We have the vent and the roof manway, a platform. So this is a bit description of facilities that you can find in a typical oil and gas platform. Let's give a bit description of the process description in this facility. Now, the crude oil from the well gets into a manifold. From the inlet manifold, the test header is tied into this part to connect to this test separator. Once if the facility is in test mode, the test separator is to test the crude to know if it's a high pressure well or a low pressure crude. So if it's a low pressure crude or a high pressure where separation occurs, a separator separates a gas from a liquid line. So if it's a two-phase separator, it separates gas and liquid. The gas is routed in this place, while the liquid comes here. A three-phase separator separates gas, water, and crude oil. So if it's a high pressure well, the high pressure line of the high pressure crude goes through this and is routed to a to the high pressure separator. If it's a low pressure well, it goes through here and is routed to the low pressure separator. While the gases, if it's a high pressure gas that is being flashed off from this test separator, it is this yellow pipe is the gas line of high pressure gas and is routed to a high pressure gas header. If it's a low pressure gas, it's routed through this red line and it's routed to a a low pressure gas header. So once the facility is in operation, crude from the high pressure header in the inlet manifold is tied into this flange together with high pressure crude from the test separator. That are collected together here and routed into this HP separator. The HP separator can be, for instance, be operating at 10 bar, and it separates gas is flashed off in this line, and this gas goes into the high pressure gas line, while the liquid is routed to the LP separator. Now, crude also from a low pressure line through the LP header in the inlet manifold is tied into this flange together with crude from this high pressure line comes in here in this line, and crude from the test separator comes into here. They're all routed together to this LP separator that might be operating probably at 5 bar. Now, at the HP separator, for instance, gas of a volume of 7 million scope can be flashed up on this side. Now, not the entire gas are being separated from the liquid line. So the entering gas goes into this liquid line and gets to this LP separator. As the pressure drops down, this LP may be probably operating at 5 bar. As the pressure drops, entering gas are being flashed off. So the gases from this LP separator is routed to the LP header, this red line, while the gases from the high pressure separator is routed to the high pressure gas line, this yellow pipeline. Why all relief lines, these are relief lines, gases flashed up from the relief valve. Some quarters, these relief valves are all routed to a particular header, and all are all routed to this bigger pipeline. So the HP gas line is routed to this header, the LP gas line is routed to this header, and the relief line is routed to this header. This is a bigger pipe size of 16 inch, it could be 18 inch as well. Now, there are some critical elements that ensures that the operating pressure of this valve is maintained. For instance, for the LP separator, we have a pressure control valve. This ensures that the operating pressure of 5 bar is maintained in this LP separator. When there is a process offset, it is relieved on this. It is relieved on this relief valve and all routed to this header. For the high pressure separator, we have a PCV, pressure control valve, or in some quarter it's called pressure safety valve. So this pressure control valve ensures that the HP separator is always operating, for instance, within that 10 bar. These are critical elements. So in most critical elements like this, we do have a bypass once maintenance is carried out on this PCV. So this piping routing or connection is just to show a bypass valve. The same for the LP gas header. Now, also we have another critical element, which is the level control valve. It controls the level within this separator. Most separators operate at half filled level. So this level control valve ensures that the half filled level is maintained. Okay. Now, all the liquid line is routed to this such vessel, while the gas line is routed to this flare knocker drum. Now, in the surge vessel that operates in a lower pressure compared to the LP separator. So, for instance, this surge vessel could be operating at 2 bar or 2.4 bar. Any entering gas is further flashed off on this blue pipeline. Let me hide this tank again for easy demonstration. Trying to get my mouse. Okay. Trying to get the mouse. Well, okay, send the mouse. Yeah, so we click this, we click this, we click this, and hide this vessel. So I can now navigate easily. Well, okay, so I come here. So the relief line goes, the relief line comes and gets into this header. So all gases and the gas outlets, the relief line is the yellow line, then the gas outlets on this surge vessel is this blue line. They're all routed so into this bigger pipe header and is now routed into the surge vessel. So from the surge vessel, the gas is safely routed through here to a flex stack. This pipeline is routed to this purple pipeline. It's routed from here to the flex stack for gas flaring. Now, why the liquid serves in as a suction for this pump. So we can see the pump arrangement. For pump sizing and selection, I have a YouTube channel, a video on it on YouTube. You can Google Kingsley AK and you see a video explaining pump sizing, pump selection, line sizing as well. You can check that. Okay, let's bring our tank back. And let's hide this surge vessel and this flare knocker drum so that we can easily navigate the tank. Okay. So from the pump takes suction from the surge vessel and pump the liquid into the storage tank. So this is a bit description of the process activities in this on this platform. Now, in the design of this platform, as well as the process vessels, the pipe routing, and the structural members, various engineering disciplines come together and act as a team. So, for instance, let me bring out this surge vessel and the knocker drum. For instance, here, okay. For instance, based on the physiochemical property of the crude and the production per day, the process engineer carry out a detailed engineering design to size the separator. And he can tell the mechanical engineer that this separator is 50 feet tan to tan length and 60-inch diameter. The mechanical engineer will take this information and carry out detailed mechanical design of this separator using PVI lights. One of its results that serves an input to the structural engineer is the weight of this vessel. In carrying out detailed mechanical engineering design, we factor in all load cases, ensure that the erection load case, the shutdown load case, the operational load case are all satisfied. The weight from this vessel is given to the structural engineer to carry out his own design. Another deliverable is, another input is the nozzle orientation, which the piping engineer, which serves an input to the piping engineer. The piping engineer, in carrying out his pipe routing, has some consideration in his faculty, to put it that way. He's considering the P&ID developed by the process engineer, as well as the process flow diagram. In carrying out his pipe routing, he's also considering the operability and maintenance, so that the operator can have easy access to operate the valves or and any other necessary activities. In carrying out his pipe routing, you also factor in accessibility, as we have here. So that operator can easily have access to other equipment or vessel. And also, in carrying out his pipe routing, we also consider the plot layout of the facility. So this one of the ways that various disciplines work together as a team. In some facility, you could have some more additional equipment depending on the client's objective. For instance, if we are to have a gas, water, crude separation, so we'll be talking of a 3-phase horizontal separator as against 2-phase horizontal separator we have here. So we'll be having additional equipment such as a line heater, a electrostatic coalescer, a heat exchanger, either a shell and tube or a plate type heat exchanger. We could have a gas flotation unit or hydrocyclone. So this is a bit explanation of this facility. Hope you enjoyed the video and hope it added value to your disciplines. My name is Kingsley. Thank you for watching.